Hello, welcome to my channel. In this video, I will be discussing scalar and vector quantities. Scalar quantity are quantities that have only magnitude but no direction. And usually, the, their values are usually in numbers with no reference to direction. An example of scalar quantities are listed: distance, speed, mass, temperature, energy, time. When we're talking about distance, it's only specified in terms of values or no direction. For example, we can say 10 meters. There's no need of mentioning direction. Same thing with speed, mass, temperature. All these things, they only have values but no direction. Okay, they have only magnitude but no direction. And we can perform mathematical operations with them: addition, subtraction, multiplication, and division. Vector quantities, they are quantities that has both magnitude and direction, and usually they are represented with arrows, with the size of the arrow signifying the magnitude and the head of the arrow signifying the direction of the vector. Example of vectors include displacement, velocity, acceleration, force, and momentum. All this has both magnitude and direction. This table shows the difference between vector and scalar quantities. In terms of their definition, like I said earlier, scalar has only magnitude but no direction, while vectors have both magnitude and direction. Examples for scalar quantity. Example include speed, distance, time, and temperature, while vector quantity example include velocity, displacement, force, and acceleration. Usually, scalar quantity are represented only with numbers, while vector quantity are represented with arrows and the what? And the bold symbol sometimes like this. Okay. For scalar quantities, we can perform arithmetic operations with them, while vector quantity may have some set of rules that are used in calculating their additions, okay, which we'll talk about later. Position is another concept that is mentioned in JAMB UTME syllabus that you need to know about, and it refers to the location of an object in space relative to a reference point or origin. It is a vector quantity, and usually it is described using coordinate system. The most commonly used coordinate system is the Cartesian system, the Cartesian coordinate system, which has both it has x, y, and z direction. But the ones that we commonly use are the x and y's. I'm sure you have at one point or the other plotted paragraph for maybe simultaneous equation or quadratic equation while you were in secondary school. So this is Cartesian coordinate. Okay. The only problem that you may have, I know, is the z axis, which cannot be drawn on the paper and is only relevant in 3D space. Okay. If you want to understand this axis, just hold up your hand like this. Hold your leg, hold your left, hold your left hand up and make a fist with it. Point your index finger up and your middle finger point it to your right side. Okay, like this. Then your thumb point it to yourself. Just hold it out like that. You see my hand like this. This index finger represents the y axis in the positive direction. The middle finger represents the x axis in the positive direction, while the thumb pointing at you, my thumb pointing at me now, represents the z axis. That is the z axis in positive direction. Okay, and this axis are used to represent the position of a body. And the origin, you can only draw the y and x axis on a paper. The z axis is assumed to either come out of the paper that you are drawing. And usually, position usually have a reference point. And when you are using the Cartesian system, the 0, comma 0 is the reference point. Okay. Usually the position is represented with two or three figures which represents the x, y, and z in a bracket, each separated by comma x, comma y, comma z. But most of the times, you only use x and y, okay, because that's what you can see on the paper and that's what you can draw on the paper. So position is usually measured with reference to the origin of both the x and y axis. This is the positive direction for the y-axis and this is negative direction. For the x-axis, sorry, this is x-axis. This is the positive direction and this is the negative direction. So if I say, let's divide it into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I say a body is at 3, comma 4, it means it's on the x-axis is at 3 and on the y-axis is at 4. So this is the position of the body. Okay, that's how position is measured relative to a chosen point, and in this case, the chosen points will be the origin 0, comma 0. Another thing that is specifically mentioned in the JAMB UTME syllabus is the distance and displacements. You need to know the difference between the two. Distance is the total length of the path traveled by an object, regardless of the direction, and it is a scalar quantity, while displacement is the shortest straight line distance between an object's initial and the final position. It is a vector quantity. Let me explain. Let's see, let's use our Cartesian system now. Let's say a car here traveled 5 kilometers along the y-axis, okay, and turn right along the x-axis and travel 5 kilometer 5 kilometer. Okay, the total distance traveled by this car is 5 here plus 5 here. Okay, so the distance is 5 plus 5, which is equals to 10. But the displacement is the shortest distance like this. Okay, so you know This place is 5 kilometer and this place is 5 kilometer. So you can get the displacement using the Pythagoras theory because this form a right angle triangle. And the displacement, let's represent it with r. Okay, so the r squared is equals to 5 squared, which is this, plus 5 squared, which is this, right? And that will be r squared is equals to 25 plus 25, which is equals to 50. So r will be equals to square root of 50, right? So you can see that the displacement is different from the distance. Okay, now that is how far the displacement is from the origin. You can also get the direction by calculating the angle here. Okay, let's call it angle theta. Hmm? So if you want to calculate this angle, you know, you can use tan theta is equals to opposite over adjacent, which is equals to 1. So theta, the angle, is equals to tan inverse of 1. Okay, which I presume will be, which will be equals to 45 degree. So the displacement is root of 5, root of 50 kilometer. You can press this one with your calculator, and which is at angle 45 degree to the y axis, right? So this is displacement, which specify the magnitude and the direction, while this is the distance traveled by the car. So in summary, distance is a scalar quantity, okay, which only has magnitude, while displacement is a vector quantity. Okay. Now another example. If an object travels in a circle like this, let's say the circumference of the circle, let's say the object starts from this place, right? And travel along this direction and come back to that same spot. Okay. What is the distance traveled by this object? The distance traveled by this object is the circumference of this cycle. If the circumference of the cycle is 10 kilometer, then the distance will be equals to 10 kilometer. Okay, but the displacement for this object that's travel now is equals to 0. The reason is that it came back to its starting point. So that is displacement. The displacement is equals to 0 while the distance is 10 kilometer. So in summary, displacement is the shortest distance from the reference point. Okay, while the distance is the actual length of the path taken by the object. The actual length of the path taken by the subject is the circumference of the cycle, which we assume to be 10 kilometers. Okay. This table shows the difference between position, distance, and displacement. You can see that position and displacement are vector quantity because they have both magnitude and direction, while distance is scalar quantity. Okay, and don't forget their definitions. Also, the value, the magnitude of distance is always positive. Take note of that. Okay, and for position, it's usually fixed for a given point, while for displacement can be positive, negative, or even 0. Okay, and the direction, vectors have direction, right? Take note of that. while distance, which is a scalar quantity, doesn't have direction. And their SI units are the same thing. Having gone through through these scalar and vectors quantity, let's look at some questions. Question one: position of an object is defined as. I believe you should be able to know this because we talked about it in the lecture. Okay, you can rattle your brain on bits so that you can consolidate on what you have had in the lecture. Okay, distance, the definition is there. Okay, then the displacement, scalar quantity, vector quantity. The representation for vector, don't forget, is arrow, the length of which represent the magnitude and the direction. Okay, the edge represent the direction. Okay, which property is not true for scalar quantity? The sum of two scalar quantities results in scalar quantity. Okay, which of this is a scalar quantity? I believe you should know this. Displacements can be negative. Can it be negative? Okay, so write your brain on that. The object is slowing down. This indicates the object is slowing down. No, that is false. The object has moved opposite to the reference points. This is true. Velocity is zero. This is false. So the correct answer here is B. Okay. Don't forget that for displacements, we have a reference point, right? And when the objects move in opposite direction to that reference point, its displacement will be negative. If a person walks 10 meter east and then 10 meter west, their displacement is, I believe you should be able to do this. Don't forget your cardinal points: north, south, west, east. So 10 meter east and then 10 meter west. What's the displacement? Of course, body will be back to its starting point. So the displacement will be zero. Okay. Characteristics of distance. You can go through these questions. They are questions that you can solve. Comment your answer in the section below. And don't forget to subscribe to my channel. Like this video and share for others to benefit. Click the bell icon for you to get notified when I upload new videos. Okay. So you can go through the questions, write your answer in the section below, and let's open up discussion. Thank you for listening. Don't forget to like, share, and subscribe. Till I see you in my next video, take care. Bye bye.